Top right is top right, and point currently doesn't actually really do anything. So currently point bottom left, but that's just happens to be a coincidence. So now the next valid numbers are overlap and side lap. So overlap and side lap actually control how much the lines, when you're taking a photo, how much overlap you get between the photos as you're flying up the line, and how much side lap you get is between lines. So if, as an example, if I turn on footprints again and I change the overlap to 0, you'll notice that I get so if you actually look on the lines, you'll notice that I'm getting very few shots on the actual thing. I'm actually getting, but the reason I'm getting more than one at the moment is because I actually have side lap. If I set them both to 0, I only get 6 photos. So obviously 6 photos would, to make this work, because there's nowhere near enough. So if I change the overlap to say 10%, you can see the sketch of the outline. You can see that there's a little bit of overlap there, a little bit of overlap there. So normally, and the one thing you'll notice here as well is that you actually don't get overlap here. Now the reason for this is because the ground actually goes up. So this comes back to that ground elevation thing I was talking about before. So just from looking at this, I can tell down here is 36 meters down the bottom, and towards the top it must get higher, and that must be close to where the 42 meters is, because we're getting closer to the ground. The actual the amount of ground the camera lens sees is actually less. So what we were doing, this is the reason for using 70% overlap. So 70% overlap, so you can see now that we're getting a lot better coverage. We're still only getting 1 photo right at the very top at the grid, but so far I don't have any side lap. As we add side lap back in as well, you'll see that it goes back to its nice, fairly dense point cloud number of photos to cover the entire area. So that's all the main settings. You'll notice that I skipped over distance between lines. So if you pick a camera, you can't actually change this because this number is automatically calculated. If you didn't pick a camera, so if I were to get rid of that, you can actually change this number if you wanted to manually control it for some reason. But in this scenario, I'm going to go back to just using the camera profile. 3 options are 3 tick boxes. So this is what I was talking about before with the different types of grid. So this is what you get is a normal grid that we the next one is, this is an option to enable, is a cross grid. So what it does is it will fly north to south, like in my sample here. Turn on cross grid, it will actually fly north to south and east to west. So I'm just going to quickly go back and turn off footprints to get rid of that so you can see that more clearly. So as I turn it on, so as you can tell, if by flying across grid over a small area, you make sure you get a lot of coverage. Where this is, if you needed to get the side profile of buildings, so if flying north to south, so if, as an example, if I fly north to south, I'll get a very good shot of, say, this wall here. The wall will only be oblique angled from this line, and this line. So that'll be 3 shots of this flat. Whereas if I do it this way, I will get additional shots of that flat wall as well. So what it allows is a lot more points to allow a better reconstruction using photogrammetry software. So if I turn on footprint again, you'll notice that when I turn on grid, so obviously I don't have super good coverage on the outside. I've got pretty good coverage. I'm getting maybe 6 photos on the outer edges, but when I turn, that jumps to 8+. So I couldn't tell you how many I am getting, but it's going to be more than 8. Currently Mission Planner only shows a maximum of 8, but I'm pretty sure a lot more than 8. So that
is cross-grid. So what I'm going to do is I'll turn off footprint. So I haven't made a very good example. So this is a quick look at corridor. It doesn't look very good at the moment. So what I'll do is I'm just going to jump out and make a better polygon that is for a corridor. So under the polygon, so I click that over here, clear the polygon, and I'm just going to zoom out. So what I'm going to do is click it, draw a polygon. So I'm going to go there, there. So corridor is really for sort of road or something similar to a road, river, power line, whatever you wanted. So there's currently a bug in Mission Planner where it draws this extra line here. That's because obviously I don't know that you're going to be drawing a corridor just yet. Where I still think you may be going a polygon or a survey grid. So what we'll do is we'll just go straight to survey grid. So currently that's opened here. There is a lot of points. So I'm going to turn that into a corridor. Okay, so what this does is it will fly down the and then turn around and fly back down the line next to it. So currently our corridor width is set to 100 meters. So let's change that corridor width. It's using the same stuff as before, so we're still using the same camera, we're still using all of that, and the distance between lines is still 10 meters. So using that maths, I can say our center line plus 10 meters, so let's make this 11 meters, and I should get one line either side. Oh, maybe not. I need to double it, so let's go 22 meters. There we go. So what that'll do is that'll fly that line and get the corridor width of 22 meters. So yeah, as I increase this number, it will fly more and more lines to try and get your corridor width. So depending on the width of the rule or whatever it is you needed to do, and this is obviously using 10 meters there as well. So it's really, so currently we're flying quite a wide line there. For a road, you probably would never have to actually fly that wide. Like, so if I reduce the altitude, you can see that it gets more lines. And at that point, maybe we're only fly 30, a total corridor width of 30 meters. So that's probably more realistic there. You get the road, the shoulder of the road, and just into the start of the people's properties. So for doing road surveys or road ASCONs or that other type of thing. So with this, again, if you needed to move a point, you can do that as well. So I'll just turn off markers, I'll zoom in. I don't like this point, so what I'm going to do, I'm going to move it. So as you can see, I can move the point wherever I want to move it. So that looks more online there. So I can do this with all of the points as well. So if I didn't move them in the right spot to start with, which as you saw, I did it quite quick, but I'm happy with the result. So so that is an example of a corridor. So our next one is spiral. So what I'll do is I'm just going to moving ahead with the spiral as it is. It's probably not really ideal, but we'll do it anyway because it's such a large area. We're going to do a spiral over. So this is a spiral. So we start from where we're starting from home at the moment. So we're going to be starting probably from over here somewhere. There's waypoint 2. So we're starting from right there, which our home is, so that makes sense. So this is a spiral. So the most common use of this is for rovers, for something like a lawnmower or for spraying, some other purpose. Obviously, this can be used with a plane or a quadcopter, but the original intent was for a rover driving along the entire area. So again, 3 meters, 3.8 meters between lines here, and it just drives around doing different types. Like everything you saw before, you can drag the markers around the edge if you want to, and it will dynamically create stuff.
It's not, I will say it's not 100% perfect. Like you can see a bit of an error going on here, but that really depends on the tool you're using. So for simple polygons, non-self-intersecting polygons, obviously it works pretty well. If you make them a lot more complicated, then things get a lot more difficult. So that of a spiral. So that's pretty much all of those. So I'll turn off spiral and we'll go back to just a normal grid. My altitude up a bit so we're not flying so many points. Okay, so the next options are the copter specific options is delay at waypoint. What you can do here is if I set this to 1, what this will do is when it flies to the end of the line, it'll stop for 1 second and then continue on to the next line. Where this helps is when you want more control, and sometimes ArduCopters will not take a photo, may not take photos towards the end of the line, and the quickest, this is actually a bug in ArduPilot, but I think it's actually fixed now, but in older versions you'll come across this problem where it the corner at the end of a line, and the best way to get around this is either to add a delay or to set the lead out maybe longer, so when it cuts the corner it's in the lead out area anyway. So there's a couple of ways to get around that, and that's the 2 ways that I'm aware of. It's heading hold. So what heading hold does is, say you're in a copter and you want it to face north the entire time, but you want it to fly this pattern here. So you're on a 45 degree, but you want it to be pointing north the entire time. So using that, I can just decrease the numbers here, and it will actually fly in the opposite direction, which does not appear to be working for me at the moment. Getting hold of the opposite direction, so backwards flying the line or forwards flying the line. Okay, so unlock from grid, there we go, 0. So if I unlock it from the grid, so now I can make it point north the entire flight, even though it may be flying, it'll be forward and to the right over here, and then it'll be flying backwards to the left on the return line. So it's one way of making sure that the camera, if you had a requirement for the camera to be facing a specific way or some other thing, if you were flying a different type of sensor, whether it, say it was something, a magnetic sensor of some description, and it need to be always pointing north, so you can make the copter fly any direction you want and keep the copter itself always pointing north, but it'll just lean a different way to move in that direction. So I'll just turn that off for a second. And so the last option in the copter options is spline entry and exit. So what this does is it'll actually spline on the lead in and lead out. Lead in and lead out, yes. So what this does is it makes a nice smooth path. So as you can see, it's got square corners. Putting a spline there will mean that it won't really have a square corner. So it will actually fly out and then fly out. Current survey grid doesn't show this, but it will actually do that quite fine. So, so what I'll do is I'm going to leave spline entry and exit. And the last one is a plane option, which actually works on copter as well. So if for some reason, if you wanted to come out this line here and then instead of flying down the line or to fly down this line over here instead, you can change this number here. So it actually changes basically it's a skipper line. So as you can see, this one flies up here and then to this line and then flies back. If I change that to 2, it'll skip 2 lines, 3 lines, and so on. So normally for planes, you'd use, because a plane can't turn around in that distance. So in this example, it's 14 meters. A plane cannot turn around in that distance. So by changing the minimum lane separation to 1, the plane's going to have what? close to 30 meters to turn around, bank around and get back online. Obviously, if I change that to 2, then it's going to have even more. So we skipped 1 line, 2 lines, and we fly down the 3rd line. So that's a very good option for plane. It does work on copter as well, but for copter, it's not really necessary good spot. So, and the last option is camera config. So what you'll see here is, so in my camera, the Sony A7, I've set up for a 20mm focal length lens, and the photos it takes are 6,000 by 4,000 pixels, and the sensor width as well. So what this is using the numbers is calculating a centimeters per pixel based on the current altitude, and that gives the vertical field of view, which you actually notice that these numbers are down here on the bottom, and they are the same numbers as the footprint. So those numbers there. So if let's just to say the next 16mm, and I go back to here, you'll see that these numbers have changed. Our centimeters per pixel now go to the 1.3 centimeters per pixel. But our vertical and horizontal field of view go to 60 by 40 meters. So a much larger field of view, and that's based on the focal length of the lens on the camera. So next 525mm, again, same image width, same sensor width, different focal length, and now we've gone to 38.4 by 25 for the footprints. So if I turn footprints on, you can see there's a lot of photos. So there's 876 photos here, and we've got the footprint coverage there. So by the look of it, a lot of these footprints are getting about 4 overlapping photos. Down the bottom, we're getting a lot more, and the reason for this is we're going from to 56 meters in this example. So there is, what, 15 meters of difference between the bottom of this hill and the top of this hill up here. So the reason for that variance there. If I were to turn on cross grid, obviously we get very good coverage, just like we saw before. Very good coverage when we turn on cross grid, and you get of all the buildings, all the houses, and all the other things. With photogrammetry, obviously the more photos you can get from more different angles, the better. Different oblique profiles of certain objects, whether it be a tree, a house, a building, a tower, any of that stuff. So I'm just going to footprints again, and yeah, so that is pretty much a guide to. Oh, one thing I missed is the trigger method. Method is how ArduPilot is triggering the camera. So at the moment, the default method is cam trigger distance, which what that means is when it enters the grid, it's a number, the cam trigger distance, which is our 11 meters at the moment. Oh, it's 7 meters, sorry. 7 meters between images. So 7 meters, cam trigger distance is automatically going to trigger the camera. So it should, which means a photo every 1.5 seconds, and with a recommended shutter speed. Total flight time for this mission, 33 minutes. So yeah, that's that. You can do Digicam control. That is actually not really more. If you're using a very old version of ArduPilot, you would use that. Do repeat servo. So if you wanted to manually control the servo for some reason, the cost of using this option here is it creates a lot more waypoints, and you might hit that ArduPilot waypoint limit by using this method, whereas the distance will be a lot more efficient and a lot less waypoints. And do set servo is again the same, controls the servo going high and low based on being in and out of the grid. So that's pretty much everything here. That's everything to do with the survey grid. So one more thing is we'll have a quick look at face map, and I'll quickly come back to that afterwards to give you a rough idea on how you would actually program the mission it and actually fly out. So what we'll do is, let's pretend we wanted to fly the front of this house here. So what I'm going to do is I'm going to draw a polygon. Let's fly from here to place map. I'm just going to pretend that there's a cliff right here. So there's a sort of a cliff at the front of this house here, and let's pretend there's one over here as well. So we've got the points. What we're going to do is map tools and go auto waypoint, sorry, and go to face map. So that will give you a screen like this. So our original line, and you can see what it's doing here. So at the moment, what that's doing is that's actually flying from that line, and it would actually be flying. So this line here is actually this bottom row here. So let's change some of the numbers here. So again, Sony, let's use the next 5 16mm. I'm going to direction, so I'm going to fly up the hill instead of down the hill. So I actually get a map of the entire thing. There's a few different to adjust in here. So let's go to bench height. So the bench height, so this is all illustrated. As you adjust the numbers, you can see a rough representation of what you're going to get. And then is what kind of angle it's on. Say you wanted to fly a sloped hill or something similar. So let's go back to 90 for that. And then